Okay, good morning, everyone. Thank you for joining us today. My name is Jesus Mingarro. I lead the sales team here at Prosperon, and with me is Robert Mandeville, who's been a DBA for over 15 years, and I think the last 5 have been very much focused on database performance, and is now a product marketing manager for SolarWinds. Rob, are you with us?
I am, yes, thank you.
So how many hats have you worn on those 15 years? Because it may be quite a few.
I lost count. But among them were definitely as a production DBA, developer, data modeler, architect, you name it. I've probably even waited some tables at some point.
Blimey. And what are you going to talk about today, Rob? Obviously, the last session that we had was about pointing out the differences between what performance and health is when monitoring databases. What's today's topic?
Yeah, so today's topic is kind of interesting to me, and it's a little more philosophical in nature, but it's talking about databases without bounds, meaning as we live in this crazy world where resources continue to get cheaper and cheaper and more powerful and faster clock speeds on chip architecture and all that good stuff. Where is this kind of leading, and is our current mindset regarding monitoring, does it still make sense, or do we need to kind of evolve?
That's a fair point. I'm sure that 20 years ago, someone raised the same topic before virtualization was a reality, I guess. So do you think that we're very far off from that, I guess, hypothetical scenario?
Well, the way I see it, we continue to move in this direction. So, are we very far off? It depends. Some of the technology underlying, our database infrastructure at this point is very mature. Some of it not quite. Like some have made absolutely leaps and bounds and quantum leaps as far as performance goes, and the compute versus cost model has really grown exponentially. And then others have lagged a little bit, specifically like storage comes to mind.
Absolutely. It's probably the most expensive one as well, so no
Right.
wonder.
Right.
Okay, so let's dive in. Just a quick reminder to everyone, today's webinar is interactive and it's very, very important that we come with your participation so that we can keep this session as useful as possible and obviously ensure that you walk away with valuable insight. For that, we're going to have primarily 2 ways of getting your input. The first one is going to be by voting on the polls that we're going to be displaying throughout the session. And we'll be asking you a couple of questions, and we'd kindly request that you submit your answer. It's just click your answer and obviously you vote. And based on the responses, we can still better the content that we display and the conversation and obviously hypothetical scenarios. The other way of interacting is going to be direct questions, and for that you can type them on the chat box. We'll also have a Q&A session at the end, but we'll be monitoring this closely. So even if we are not able to answer them in real time, please do put your questions there. So we're gonna launch the first poll, and the poll is: what database platforms do you run in your environment? So I'm going to launch the poll. If you guys could please vote, and I'll share the screens. So 80% of you have already voted. So I'm gonna close the poll and share the results. I think they are perhaps expected, I would say. So what do you think, Rob?
Yeah, that's pretty normal as far as distribution and what I hear back from some other folks and stuff and some other polls that I've seen. So not totally unexpected. One thing I would ask is if anybody wants to chime into the chat. This was the results of the poll, but does this mean that your organizations actually run multiple vendors within the same environment? Meaning, like within your company, you're running SQL Server and Oracle and maybe some MySQL?
It's probably going to be, everyone could check all that applies, so it's probably going to be a mix, I would say, even though Microsoft SQL probably is one of the market leaders. I'm sure that there's going to be a mixture of databases based on the applications that they are running.
And actually, from what I've seen from industry analysts like Gartner and Forrester and stuff, SQL Server is a growing platform. Oracle is shrinking a little bit, DB2 is shrinking probably the most out of any database platform that is being reported on. Cloud platform, believe it or not, like the Amazon RDS is the fastest growing platform just in general, but of course that takes in many different flavors, including like Aurora, also some NoSQL kind of databases as well.
Absolutely. Okay, so moving on, just a bit of introduction about who Prosperon are, with the leading UK authority on deploying, tuning, and training users of SolarWinds products. And primarily, there's three main reasons or categories why you guys engage with us. So we have customers that are already using SolarWinds, and some of them are new to the tool, and some of them have been using it for as long as we've been in business. But the common denominator is that they are looking to improve what you get out of the tool. So you may be looking for ways of optimizing the platform. It may be either based on performance or usability. Some of the time you could be looking at implementing best practices or automation, or perhaps assistance with upgrading the modules. You know that obviously SolarWinds is pretty active and would release major updates around twice a year. Perhaps you may be looking at ways of increasing the efficiency of the tool by integrating it with other system of your ecosystem. And we also engage before implementation, perhaps when SolarWinds is being considered or evaluated against other options. These type of customers may be looking to understand the implications of implementing a platform like SolarWinds, perhaps recommendations around architectural designs, planning, and in certain scenarios, they may be looking for a company that can document them, from the commercial aspects all the way down to low-level designs, etc. And finally, some of you can also reach out to us for assistance once the tool has been deployed and is in place. This will include both technical support as well as general advice on how to achieve certain things or get a second opinion around the strategy, etc. What backs up the level of service and customer retention is primarily our experience. So when we were founded, SolarWinds had only one product, and that was NPM. And it was around 11 years ago. So if my memory serves me well, I think it was NPM version 7. So without going into too much detail, I'm sure that pretty much all of you know that SolarWinds has grown astronomically since. So throughout all their journey, we've been solely and completely focused on SolarWinds, nothing else. SolarWinds is all we do. We breathe monitoring and have been engaged with some of the largest deployments of SolarWinds in Europe. Pretty much all of engineers are SolarWinds certified, and on the screen you can see that they are on site 1 of every 3 days throughout the year. So what this means is that we get exposure to highly secure installations, to deployments large and small, and pretty much across every vertical. So we tend to understand the hurdles that you need to go through and that the resources are always limited. So we always aim at engaging with you in the most efficient way possible, and while keeping integrity as the foundation of this, which obviously results on better value for you. Finally, the next screen outlines the added value that is provided when you guys renew your annual license, your annual maintenance with Prosperon. Support is by far one of the major ones because we complement SolarWinds on support, aiming to reduce the time that it takes for you to resolve issues. In practical terms, what it means is that when you're requesting support to Prosperon, either you'll get a response from us directly on the spot, or if for whatever reason it needs to be escalated to SolarWinds, we'll manage the ticket on your behalf. So on top of that, you'll get a free health check of your SolarWinds platform. And the reason why this is relevant is because we probably performed more than 150 health checks over the last couple of years, and we keep seeing the same gaps over and over. Not necessarily talking about how attractive or clever your network maps up, but rather the fact that not many of you are using the advanced features that are available in SolarWinds, perhaps as well as you could. And in some cases, they are not really being used at all. And what's most important is how much they could contribute in reducing the time that you need to spend managing the SolarWinds platform itself. So you could implement automation tasks whenever possible and help reducing that burden. The good news, though, is that the SolarWinds module that we will be discussing in the end has pretty much all this functionality already built into the tool, but I'll obviously leave Rob to explain this better. So without further ado, Rob, the stage is yours.
Yeah, thank you so much. And one of the great powers of SolarWinds is that we do have products that really focus on specific IT disciplines. So whether you're a network admin or a database administrator or a system admin or a storage admin, we've got a product for you to give you the visibility into your environment that you need. Now, also one of the advantages of is being able to stitch all these together in an end-to-end kind of visibility platform, meaning the Orion platform. Um, the last major release of Orion products introduced this perf stack. I don't know if, Jesus, I know you're familiar with it. Hopefully your customers are too, because it's really the ability to bring in metrics or any kind of statistical value from any tier within the Orion platform to determine exactly where the performance issues are originating from, whether it be at the storage tier, whether it be from the network side, whether it be from the a server side or application. Um, and that's one of the exciting things that we are going to be coming out with is adding database specific metrics to the perf stack environment
I
for
think
view.
that's been probably the second major leap from SolarWinds, because obviously SolarWinds has always been very popular and the motto was single pane of glass and whatnot. But I think customers were still spending 12 or 14 hours, switching from tab to, even though you had a single console and all the products feeding into it. So then they released Abstract, and it was, the ability to see everything in context and see the dependencies and so on. And it was a major leap. But with PerStack, I think they've gone beyond that, because as you said, it's not just seeing the dependencies, it's being able to correlate all the different metrics from all the different components that may be part of an application or your troubleshooting routine, if that makes sense. So I think it's been great, and more people are embracing it.
Yeah, that's spot on. So version 7, huh? That's been a while.
Version 7, yeah. A very long while there.
All right, excellent. Um, yeah, I was going to say thank you for advancing the slide there. So let's launch into this topic of databases without bounds. And I want everybody to notice the title of the slide, and that was not a mistake. So why resources mattered. And I use the past tense here because, and again, very intentionally. Now they still matter, but less and less so. So if you remember the old times, and I might be dating myself a little bit here, but I remember having to beg for additional resources. I had to go get budget approved, CapEx. I had to answer like a 20-page questionnaire, kind of justifying it. Then when it did get approved, it could take weeks for the vendor to deliver, let's say the new CPU or disk or memory or whatever it was that I was acquiring. Then I had to schedule a change window and an outage, which could take another couple weeks. So, it could be months until I actually got new resources deployed to my physical servers. So I don't know about you guys, but this was absolutely a significant pain for me. Then I was introduced to hypervisors, but I was skeptical at first, probably like a lot of people, and especially as a DBA, I think we were one of the last bastions of holdout for going to virtualization. Initially, it was not very performant from an I/O perspective, and since we know that databases are quite I/O intensive, that did not go over well with me. I was definitely a little bit hesitant to move on to the hypervisor platform. Um, so I think because of this fear, that definitely prevented me from initially moving P2V, physical to virtual. So at some time, in the past, the physical resources were definitely precious. They were a significant cost driver. They were worth focusing on. They did matter. But those days are pretty quickly receding into the rearview mirror. Um, Another advantage that they had, though, was that they were very easy to watch and measure from like a health and resource consumption standpoint. So that did absolutely make sense once upon a time, but I would say we're quickly moving on to a new day. All right, Jesus, do you mind advancing? So what did happen to physical resources? So I'll give you a moment to kind of check out some of those laws. Okay, that last one's not really a law. That's just my way to
You need
get my
to
name
you
on
need to explain that. You need to explain that.
Yeah, exactly. It's really just a way to say that, to get my name on the slide there. But anyway,
Nice.
but really what most of those laws will talk to, and you can buy into the one that you think most accurately represents what's happening to the physical resources within IT. Moore's law, the fact that we're doubling in power or advancements every, what is it, like every 18 months or something like that, and the cost is reducing by half. And really what this means is that the compute ability per cost is growing exponentially and continues to, right? Every time we think that things are flattening out, there's a new quantum leap or some kind of new invention or something like that that really pushes the edge further. So regardless of which law you buy into and for which physical resource, it's really tough to argue against the fact that the pace of advancement is just simply amazing in the world that we live in. So we are and have been experiencing this exponential growth on the compute side. As a side note, real quick, there was a really good book that I read called The Second Machine Age that I would certainly recommend. And it's basically takes you way back to the very beginning, but we were on a very linear path as far as population growth right up until the industrial age, at which point technology kind of intervened. We found better ways to do things. We found better ways to grow food and everything. We had this inflection point where the population started to grow exponentially. And I'm not even sure where the number is now. I think we're probably approaching 8 billion people. I'm not sure, but really, in the second machine age, they say that we're probably at another inflection point right now because of the digital age, because of all of this computing power. They say the problem with that, though, is that once you're on a fairly vertical path on a graph, if kind of graphed out with just a regular scale, it's very hard to see that next inflection point because we're already fairly vertical. So that's when we have to bring in things like potentially a logarithmic scale, where if it still plots out linearly, you're actually growing exponentially. So I'll let you guys kind of do some research into that if you want, but it's actually a really fascinating book. Again, it's called The Second Machine Age. Okay. Anyway, what these laws tell us essentially is that technical resources will continue to get better and better, faster and faster, cheaper and cheaper. You look at like I mentioned earlier, the clock speeds on chip architecture nowadays, the ability to throw huge amounts of RAM at our servers nowadays. The network bandwidth has just gone through the roof. And really I would say the one technology that has kind of lacked a little bit, and it's gotten a lot better with SSDs, but is the storage side, right? We've seen some, what would you say, like 10x improvements, maybe 20x improvements with SSDs, but that's not truly the quantum leaps that we've seen from like clock speeds from a chip architecture or the huge bandwidth explosion on the network side. So, and really that is to say that all of these physical resources are being commoditized, right? So we no longer care. As long as it's performant and reliable, you don't care what kind of vendor memory you have in your servers, right? So with this continued downward price pressure on physical resources, plus all these laws that are contributing to the technological advancements that we're seeing, we are very, very quickly moving into a paradigm where hardware is essentially unlimited. And that kind of world doesn't sound that far-fetched.
It doesn't sound at all, Rob. It probably sounds like it's closer than that we actually think.
I think it is. And as we move into this day and age of machine learning and AI and stuff like that, it's tough for, let me back up a little bit. It's tough for humans to think in exponential terms. We tend to think very linearly. But as these advancements continue to happen, and as these new new abilities come online with artificial intelligence and machine learning and stuff like that, machines actually attack problems exponentially faster than we can. So I think the speed or the pace of change is going to continue to accelerate. So I think we may get there faster than we think.
The funny thing, though, is that we may not be able to think in exponential growth, but our expectations certainly do. Because when you start to be aware of how the world is changing and what the technology and the machine learning is doing for you, automatically your expectations grow exponentially as well. So it's no longer linear here. So
Absolutely, absolutely. So that the day and age where we don't have to worry about physical resource limitations, it's coming. It's definitely coming. Yeah, so digital versus virtual world. So I used to work for a company called Digital Globe, and one of my jokes was, thankfully we're finally have a digital globe because this analog one is starting to go bad.
nice.
But yeah, but the push to virtualization is huge, and it totally makes sense. And like I said, I was very reluctant at first to jump onto a hypervisor, but now I'm a true believer. There are some cons to it. There are some drawbacks, but I really think that the pros far outweigh the cons at this point. I mean, you get built-in fault tolerance, you get HA, you get the ability to establish like a DR site with a whole nother cluster and stuff like that. So it's a great way to have resources readily at your fingertips that can be provisioned very, very quickly. And case in point, with these virtual servers and stuff, really when was the last time as a DBA I had to go down and actually touch a server? For me, it's been well over probably 12 years since I've actually had to care about where that physical server resides. Okay, so our hardware is getting cheap and it's getting good. And the advantages of virtualization is that it brings a much more efficient way to allocate those resources. Physical hardware can be shared among guest operating systems, which hopefully allows us to more economically use what we have at our disposal, right? As long as not all the virtual machines or guest operating systems are hitting a peak usage at the same time, because that can cause contention, so you have to be a little bit careful about that. But for me, one of the biggest advantages was the time to provision. Again, I kind of talked about that, but instead of months, now we're talking minutes, right? They hit a button and voila, I've got more memory. So, all right, so go ahead and next slide. So the new world, what is this going to look like? We've got cheap, fast, reliable resources that can be quickly and easily provisioned. So let's take it that next step further. I mentioned just a couple minutes ago about AI, machine learning, call it what you will. But if the system can allocate resources based on need, how would that look? Like for physical hardware resources, we're essentially unlimited. Why not feed the beast? We could set up one of those self-refilling troughs. I'm thinking like those little gadgets or whatever that you feed your pet from, or that you have like a water tank in back, like a reservoir, and then it automatically fills the dish when it gets low. So we can provide this hopper of resources, and it can dynamically and automatically provision when needed. And then go one step further with machine learning and stuff that it can actually start to learn the profile of your virtual machines. In other words, it knows that machine XYZ, I should say, right? You guys say Z. XYZ will need more CPU every Tuesday night at 8 p.m. Or maybe I need to throw more power at it the first day of the month when we do month-end reporting or accounting closures or something like that. So if any of you haven't heard of machine learning, and I'd be shocked if you haven't, but if you haven't, at least now you have, and it's something for you guys to check out too, because it's a really fascinating field of study at this point.
This is already happening, however. Networks, for example, they have SDN, and this is becoming more and more of a trend now, where the router will automatically switch between connections just based on usage and predicting the type of consumption that certain applications are going to do. So it's certainly already happening in certain points within your infrastructure.
Exactly. And why would not that same functionality or ability extend to other areas?
Absolutely.
That's exactly right. So the potential here is pretty cool. And we all know where this ultimately leads, right? We're going to have the Terminator pretty soon.
Well, that's very, very gloomy. Yeah.
I know. Okay, so let's get it back on the positive track. Okay, so I'm a DBA. So what? Why should I care about this? Really, if we're moving into this all-you-can-eat model, then think about what that means for us. It means that there's no more waits for physical reads, right? Everything can live in cache. We can just throw huge amounts of RAM at it. Why regulate parallel executions at all? With the caveat that as long as the time cost of the overhead associated with processing and stitching together these multiple threads, plus the time cost of the execution of the longest thread does not exceed the time cost of the single-threaded execution, then why would not everything run in a parallel fashion? Cost-based optimization will have to get refactored, right? Because that took into account a lot of the physical resources that we're talking about, but if they're unlimited, then that kind of goes out the window. Database engine optimizers, as we know them, would have to get a complete overhaul. And this would be to account for the fact that, hey, we're no longer running on a machine from the 1980s with all these cost factors kind of built into it, because now all of those assumptions are wrong. So without practical limitations on physical resources, we have to rethink all of these things from a database item, and the future may antiquate a lot of the optimizer models that we currently see in the market. And by the way, that kind of disruption within the market is not uncommon, right? We've seen it before, we will see it again. It just means that the database engines as they currently exist certainly have to evolve.
You also mean database function as such, because I cannot think of any way of storing data. You potentially need a database, and now that you're collecting way more metrics, not just from an infrastructure perspective, but IoT and mobile phones, and your car is obviously also tracking plenty of things. You're going to have to store data in a kind of similar way, I guess.
Yeah, and indeed, that brings up a really good point. The desire or the requirement to store less data will never be here, right? I mean, we just keep piling on and piling on and piling on. But as long as the data,
we call it big data now, so
big data, yeah,
it's going to have huge data next. So.
Exactly, enormous data. Yeah, I don't even know what to call it. And that is to say that a lot of the big data brings to mind some things like Hadoop and some other NoSQL kind of databases that can just churn and burn as far as consuming new data. But there's going to be a convergence, right? Some of those NoSQL kind of databases are realizing that there is a very practical reason why we have to have and adhere to ACID principles. And the existing RDBMS platforms, the traditional ones like your Oracle and SQL Server, also realize that there is a need for some of that NoSQL, huge data consumption. So I think what you're going to find is that they're going to basically make their own platforms much more extensible to be able to be flexible like that, to consume data and store it in whatever format or fashion makes most sense. One size does not fit all. Okay, so am I actually saying just throw hardware at it, just feed the beast? Yes. No, I'm just kidding. I can just imagine it right now. There's a bunch of DBAs on the floor, like in a fetal position or something like that, saying, no, Rob, don't say that. I would never advocate something overly simplistic like that. There are lots of other factors that come into play. One of the biggest is that if we're just going to continue to throw resources at it, especially processing, then most RDBMS platforms are actually processor-based licensing, right? So just be aware that you can throw more resources at it, but definitely do so with the knowledge that it could expose your company to liability or additional costs from a software license perspective. So is it the right thing to do? Not necessarily. Your CFO would probably agree with me on that. So also from a resource standpoint, you know, it's kind of nice if we don't have to increase our footprint, reduce the power consumption, reduce the amount of physical hardware that we have to throw at things. It's kind of like working smarter, not harder, right? So there's a lot of other levers that we can pull as DBAs that we don't have to just throw hardware at it.
You mentioned Terminator before. We can probably reference Wall-E here, where they have to leave the planet just because obviously they fill it up with junk and
Feels like that's coming about too, right? So there's
indeed.
many trends that are kind of hitting us at the same time. All right, so you can move on in the slide. Okay, so I'm still a DBA. Now what? Seriously, what does this mean to me? Tuning our databases for maximum performance includes so much more than just monitoring and addressing resource consumption. Don't forget about all the other things that we do. So without the need to even think about physical resources and resource contention, our job is done, right? Not so fast, right? We've still got query tuning, transactional based, batch logic. We've got transactional external dependencies, and that's one of a little bit of a pet peeve with me. I hit this in my past experience, but developers will sometimes open up a transaction and then wrap some kind of external dependency, whether it be like a web service call, or maybe they've got to run an operating system command or parse a file or something like that. And then they'll come back into the transaction and either commit or roll back. Well, by placing that external dependency within that transaction, that thing may never come back. So they take out a lock on a resource, and all of a sudden everything gets backed up from there. Proper data modeling, and I'll kind of throw indexing in with that. Not overdoing it, especially when it comes to transactional type of database instances like OLTPs. Multi-threaded concurrency. This could actually go back up to the external dependencies and stuff where, sometimes the more threads you ramp up within your database, the worse performance gets if there's contention at specific resources, and that's where the locking and blocking comes in. Making sure that we're using the right driving tables when we're doing like nested loop joins and things like that. The inefficient plan steps. So basically this brings the optimizer back into the equation of it selects what it thinks is going to be the most efficient path to satisfy the request coming in. So if it thinks that it's going to be the lowest cost to do a full table scan or something like that and bypass an index, it'll go ahead and do that. So we have to make sure that the optimizer is making good choices, and that means all kinds of things like the indexes exist, the proper indexes exist in the first place, that statistics are valid and current, things like that to really help the optimizer. But I do also think that, as I mentioned earlier, a lot of these major database platforms are going to have to kind of rethink their cost-based or their optimization model. Okay, so yeah, go ahead.
I was going to say that DBAs are here to stay, right? They're not going to be replaced by machines. It doesn't sound like.
Oh yeah, and that's to say that our role as a DBA may morph a little bit, but that's normal, right? I say that we embrace it. We really run with it, and if you're moving into, let's say, the cloud, even because that's kind of the next big thing on the horizon, the levers that a DBA has to pull are a bit less, right? We don't necessarily have to worry about installs anymore. We don't have to worry about patches or upgrades or anything. all that is taken care of for us, even from a backup perspective. We still got to be required to make sure that we can restore the data, but a lot of that goes away. So then that begs the question, okay, for a traditional production DBA, what is left? And that's this list here, right? This is where our value add is going to come in and be apparent. So yes, the DBA is not going away.
Perfect. So let's see. Let's see how many of you have actually embraced virtualization. So there's a new polling here. If you guys could please vote. Is what percent of your database infrastructure is running on a virtual platform, regardless of which one it is. Yours can be cloud-based, obviously. I think pretty much all of you have voted. Let's share the results. And there you go.
Wow. Okay. That's a little bit less than I thought. With other polls that I've run previously, it was probably hovering right around the 80% of people that were virtualized.
I guess it also comes down to the nature of the companies that the attendees may be working for. Some companies will not have a virtual machine, and some other companies will not have a physical server. So,
true, very true.
Perfect. So, moving forward, I think I'm going to make you the presenter, Rob.
Yeah, let's go ahead and switch over. So with all this being discussed, really the bottom line from my perspective is that, with the trends and resources that we're seeing, with the huge advancements that we're seeing, the lower cost and everything, does it make sense to have monitoring that is resource consumption based, right? Now, understanding this kind of goes back to our previous discussion about health and performance. It is very important to monitor the infrastructure to make sure that there is a lack of illness or that our systems are healthy and ready to perform, ready to go. But then like saying that we're measuring the health versus the performance, they really are two different concepts. They really are, they answer two different questions. So I kind of put in the bucket of health monitoring this resource consumption, right? So if our query is taking up, let's say 10% of the CPU, is that good or bad, right? At one point back in, from a historical reference and, kind of throwing back like 15 years ago, that was important because CPU was a scarce resource. That's no longer the case. So I think that our mentality of what we monitor and how to monitor it and how we go about this from a database perspective is really morphing into this new thing, right?
As you were saying that the job itself is morphing, you probably have to concentrate on the tasks that you mentioned. So it's obviously resources, the backend patching, and so on is going to be taken care of. So
that's
I
right.
agree with that.
Yeah, that's right. And so that's really to say that if resource-based consumption is what used to be the way to monitor from a performance perspective, because resources were a big cost driver, and if that is no longer the case, then what is the right answer then? That kind of begs that question. So that is where I am going to jump into my screen here, and hopefully you all can see my page.
We can indeed.
Excellent. And so with this new world of monitoring, what does it look like? So really, this is where I've spent the last 5 years of my life and really focused on the performance aspect of it. And this has really come about as the one of the best practices for database monitoring, and regardless of what platform you're on. So the approach is called weight-based analytics. And really the idea behind it is to go and ask the database engine, what activities are you doing to satisfy end user requests or application requests, and how long are you spending doing it, right? So really, if you think about it, if anybody's familiar with bytecode instrumentation, where it's really inserting code to track where the application is spending its time. We're doing exactly the same thing. We're just leveraging the instrumentation that is provided in major RDBMS engines already. So we're just leveraging what's already there. We're asking it where it's hurting, and it's telling us. So kind of cool. This is Database Performance Analyzer. So this is the product representation of that approach of this new way of monitoring. And really, I like to start by focusing on weights and finding out where the potential bottlenecks are within our environment. And we can see here that for the most part, this memory CPU is the primary activity for queries within my database. And actually, this is fantastic. So if I had to say which activity I would want to see almost within any context for any database environment, regardless of who you are and where you are out there and what kind of database platforms you're running, it would be memory CPU. I want to see that things are actually processing. So let me back up and go into that analogy, because really a process within the database can be in one of three states, excuse me, at any given time. So it can either be running, runnable, or suspended. So if it's running, and you can think of this as like you go to a grocery store, and once you complete your shopping, you go to the front, you get to a cashier, and they process you. They check you out. And so while you're with that cashier, you're actually being processed, you're running. You could be runnable, which means your shopping is all complete. You're just waiting in line for the cashier to get done with the guy in front of you. Or you could be suspended. And suspended means you're doing some other activity, regardless of what it is. You might be trying to find the next item. You might be doing a price check on something. You might have run into a neighbor and now you're stuck talking to them. So it really means that you're not working off the job, though. You're not actually processing. You're not doing anything to kind of get the workload done. So that is represented by all the other weights within a database. A good example would be something like page IO latch, where I'm actually doing physical IO back to our storage subsystem to retrieve some data that is now going to be acted on or processed, right? So with this view, I get to see that memory CPU is our primary activity. Again, probably a really good way to look at it. And this is, again, going back and asking the database, what are you doing, where you're spending your time? If I want to see it within a very specific context of the top SQL that is doing this work, I can just flip over to that view within the tabs across the top here. And now I get a view of my top SQL statements. So hopefully this kind of makes sense to everybody, especially as a DBA, that at times it's good to be able to triangulate and find out, okay, what is my top contributing SQL statements to activity within my database? Where am I spending my time? What is the database engine doing to have to successfully return that request? Which program or application is it coming from? Which database is it hitting? And this is SQL Server, but the same navigation actually applies for Oracle. It's just that within Oracle, we really talk more about schemas rather than databases. So that's kind of how it's logically broken out. Which client machines is this traffic coming from? Which are my biggest ones that are hitting my environment? What database users? What files are getting hidden? What drives are being impacted? And last but not least, and I'll just drive into a specific time frame here, and I'll pick up specific SQL. Otherwise, I'm going to get a bunch of plans probably. Whoop. Let me pick a better one here. Do I get plans? No. This is demo data, so I apologize. There might not be a good mock-up here, but basically what it does is it allows me to drill into a specific SQL statement and then I can go look at the plan that the optimizer came up with to satisfy that request.
I think it may be because you're looking present data or even future data on your time span. I don't know if that has something to do, but I don't know if you were to switch back a few
It
hours.
could. Yeah. And that's what I was saying. This is demo data. So what we do is we kind of mock it up and then we just change the dates on the back end so that it's always present and accounted for. But yeah, it's a little bit suspect because it is just a mock-up. So yeah, that kind of gives you guys hopefully the idea though of this new way of looking at our database environments, right? If anybody has any questions about this weight-based analytics or about this, we also call it response time analysis. And the reason we call it that is that we really take it from a perspective of an end user. So in other words, they don't, Bob over in accounting does not really care what's happening underneath the hood of the database engine. He just wants to make sure that his report runs quickly, right? That he's not sitting there waiting for it. He doesn't care if it's doing page IO latch. He doesn't care if it's memory contention. He doesn't care if he's being blocked by another session. He just wants his work to complete. So having said it from that perspective, really all he cares about is the clock time on the wall. So that's really the approach that we take, and that response time from an end user perspective is the approach we take.
I think it's good to provide them with that information so that it can align their efforts to what the end users actually experiencing, obviously.
Yeah, absolutely. And really that's where probably the complaint is going to come in, right? I mean, probably the end user is not going to come to the DBA and say, hey, database 123 is slow, right? They're probably going to come in and say, hey, this application is hanging, or this application is taking a really long time to return my data. So you have to have a way to be able to map the dependency between that application and the database, and to really be able to dive in and kind of tease apart those layers. And that is a good point, because they're up to 88%, and this is a stat that we got from a survey a while ago, or maybe some Google research or something, but up to 88% of application performance issues can actually be tracked back to the database tier. So a very significant percent of performance issues are actually at the database layer.
You're saying that it's not the network? I cannot.
Still blame the network, of course.
The good argument.
Yeah, but chances are it's not the network.
So there's no question so far. I guess that everything was super clear. So people were asking questions. Please, just a reminder, if anyone has any questions, feel free to post them.
Yeah, and while we're on that topic, though, if nobody does have any questions, then that is also one of the really nice advantages of the SolarWinds suite of products. There's also a product called SAM, Server and Application Monitor. And what we've done is we have, I kind of mentioned our introduction into PerfStack and stuff, but there is already integration that is happening, so that once you integrate DPA with the Orion platform, you can actually see, and Jesus, you mentioned this through AppStack, you actually get to see that dependency tree, right? You can see which applications are hitting which database, and it really gives you that full view functionality to be able to see all the layers that could potentially be impacting performance.
I think it's important, because you did say that responsibilities are morphing. I think that a few years ago, individual teams used to be a bit more siloed. I'm just looking after databases and that's all I care. I'm just looking after servers and that's all I care. But now it's everything. It's just application delivery, regardless of, as you said, the normal user doesn't care what he's going through or what he's doing in the backend. He just wants speed and performance.
That's right. That's right. And it's kind of interesting, because you go out there and you ask different IT professionals, and some will say, I don't want anybody looking at my dirty laundry, right? But they do want to see everybody else's. So it's a very interesting phenomenon out there. I say try to be as transparent as possible. I think only good things come when we're all working from the same set of truth, the same set of data, that it becomes a much more intelligent conversation, and it moves away from the finger pointing from the blame game to, okay, we all know where the problem is because we're all looking at the same data. We can agree on that. So now what we need to focus on is fixing it or resolving it.
Absolutely. Way more efficient.
Yeah, much better conversation, I think, in general. Nobody likes to be at fault, but if you, if the finger does point back to your area of expertise, it's very nice to have, first of all, the tools to empirically identify that to say, yes, it is my problem, right? But also using a tool like Database Performance Analyzer, if it does point back to the database tier, now you can at least identify why. And that's a big part of it right there. You can empirically and definitively find root cause.
That's brilliant. So you can be the one that gets the blame the most, but also the one that fixes the most problems.
That's right. That's exactly right.
Perfect. Yep. So, Rob, are you running anything else or?
No, I think that's it at this time. I think we're coming up to the top of the hour, so I do want to be respectful of everyone's time. So I think we're good to wrap.
Absolutely. There haven't been any more questions. Oh, just one just come. My question is, let me just pop this out. I'm showing how proficient I am with GoToMeeting. What is the performance overhead of using this, or how it is hooked to get info from the database? Now, this hasn't been mentioned. So, Rob, I don't know if you could perhaps explain briefly, how DPA works and the stress that it causes, if any.
Absolutely. So really our methodology, first of all, the overhead associated with running Database Performance Analyzer in your environment is less than 1%. So the reason we can achieve such low overhead and do continuous monitoring, like 24/7 monitoring, is that we go after what's in cache already. So in other words, we only ask the database to give us information about sessions that are actively doing something against your database. When we do that, we ask for this minimum set of information, and really that's what's represented in the tabs across the top here. So we ask it what SQL is running, we ask it what databases it's running against, we ask what weight it's currently experiencing, we ask it what application it's coming from, etc. So once we collect this information, and again, that's already in cache because that session is active, we're not going after any historical things at that point, then we build up this repository of activity, right? So once we pull the data, we're done, we're out of your environment, and we store it here in our own repository. So that's how we can keep our overhead extremely, extremely low. And so we do all this agentless too, by the way.
So, I was going to say that was going to be my next question. Do you have an agent running, or how are you querying?
We do not. So we do all this through JDBC connections remotely, which that part's kind of nice too, because with some products, and especially if anybody's working on the Oracle side, and I think there were definitely some Oracle DBAs out there, if you've used grid control or OEM, then it requires you to put an agent on each of your target servers. And I worked in an environment where the agent itself actually ran away with a CPU, a whole CPU, and was utilizing it 100%. So that can definitely be an impactor on your performance.
That's the never-ending discussion, agent versus agentless and so on. But absolutely, just the overhead of the agent itself, plus the fact that you need to maintain that agent, update it when it's needed, and so on, and probably makes the conversation worthwhile. So.
Exactly, and with just one piece of software out there that does all these remote JDBC connections, if you ever need to upgrade or anything from DPA perspective, you're upgrading one spot, and then it affects everything. So that's kind of nice from an administrative or management aspect of it. And that could be a whole nother discussion about agent versus agentless, because I get the advantage of having an agent, but I've always said, like, if we do change to an agent architecture, then I'm probably going to go find another job.
Oh, strong statement.
I feel very strong. And that is to say that I definitely get the advantage of what having an agent can bring, If we had an agent, we could do a lot more stuff and collect a lot more information about the operating system. We would have access to, a very clear picture from what an end user would actually see from a server perspective. But it's that trade-off, right? Now you have to manage all those agents. Now that agent could potentially run away with your CPU or consume memory, or all kinds of bad stuff can happen.
So you obviously made clear on what side you're at, which is better.
I like to be pretty definitive on where I weigh on issues.
There's no ambiguous feeling in here, yeah.
Right. Hopefully that was clear.
Perfect. So we don't have any more questions, and we just are a minute away from the hour. Thank you everyone for attending today. I hope that you find the session very useful. There's a survey that once you close this webinar will pop up. We would request that if you can, so please complete it. That it will help us obviously plan for further webinars. Rob, once again, thank you so much for joining us today. I know how much this means to you, obviously, since it's pretty early over there.
Definitely, and thank you very much for having me, and thank everyone on the call here, the webinar, for taking a little bit of time and spending it with us.
Brilliant, a pleasure as always. All right, cheers, guys.
Cheers, thanks.